My dear friends, Prof B Oza again at your perusal. We are talking on generator protection. And as I told, there are 10 short videos of half an hour each for generator protection. We have talked up to 6, in which we have covered all faults, that is, stator faults and rotor faults. Now, in this generator protection 7, we will start with abnormalities. What are the abnormal operating conditions? So the first abnormal operating condition I am taking is unbalanced load protection. Unbalanced load means IR, IY, IB are not same. I hope everybody knows, but those who are yet students, for them, I would like to tell that balanced load means vectors IR, IY, IB are equal with reference to magnitude. Number 1. Condition number 2 is vectors IR, IY, IB are 120 degree apart. And therefore, the sum total IR plus IY plus IB vectorially is always 0. And the third very important condition is the phase sequence should be R dash Y dash B, meaning that if you plot the vectors IR, IY, IB, and if you rotate the vectors anti-clockwise, then IY will take the place of IR and IB will take the place of IY. If these 3 conditions are satisfied, load is said to be balanced. And generator must work at balanced load. Generator cannot take imbalance. In other way, generator, you cannot pass negative phase sequence currents or 0 phase sequence currents, or for that matter, you cannot pass anything other than fundamental through generator. It should be pure 50 hertz that generator should generate. But no generator can generate exact fundamental. Some distortion is there. So total harmonic distortion, THD as it is known as, up to 3% is allowed. And as far as negative phase sequence currents are concerned, 5% negative sequence current, that is 5% of fundamental, that generator can withstand for 24 hours and 365 days. So up to 5%, there is no problem. If negative phase sequence current crosses 5%, then the problem occurs. What problem will occur, that we'll see later. But let us first see that imbalance IR, IY, IB is practically impossible because major load is induction motor and induction motor is mechanical load. So induction motor consumes balanced load only. As far as other loads, single phase loads are concerned, usually single phase loads are balanced. That means if to one consumer electricity company gives R and neutral, then to other company or to other house or to other society, they will give Y and neutral, and to commercial complexes, they will give B and neutral, something like that. What I'm trying to tell is at generator end, negative phase sequence is practically impossible. So then why protection? Why protection? Why should we give protection against negative phase sequence? Yes, we have to give. Protection engineer has to give. There are 3 possible conditions under which the negative phase sequence currents can flow through generator much more than 5%. And if it flows, then what will happen? That you have to think of. You see, because of positive sequence current, the rotating magnetic field is rotating same clockwise direction. Then because of negative phase sequence current, it will rotate in anti-clockwise direction. It is a field. It is a field means it is not seen. Flux that is rotating, that you cannot see. It is not visible. And because it is not visible, it has no weight. So it will immediately change the direction. But the physical rotor, which is rotating at 3000 RPM at 50 Hertz, it will not change the direction. So, because of positive sequence current, the slip is 0. And therefore, we are rather manufacturing the rotor in one piece. It is not laminated because there are no eddy currents. There is no eddy current loss. There is no heat because of anything. But because of negative sequence current, double frequency current will flow. The frequency will be 100 Hertz. And if the negative phase sequence current is allowed to flow for more time, then it is quite possible that the generator rotor will become, that is rotor iron will become red hot, and it will endanger or it will damage the insulation of rotor winding, and rotor earth fault will occur. And rotor earth fault means heavy vibration, and heavy vibration means heavy damage to generator. Therefore, you have to provide the negative phase sequence protection. So now we'll see the causes because of which the negative phase sequence currents can flow. So one cause is open circuiting of one of the phases of or one contact of circuit breaker. Means out of 3 contacts, 1 contact becomes open. So it becomes single phasing. And single phasing means purely negative phase sequence. But you see, nowadays, the circuit breakers are manufactured in such a way that phase discrepancy protection is given. That if one pole open circuits, then all the 3 poles will open. I mean, other 2 poles which are closed will automatically open. I mean, that kind of protection is there in circuit breakers. It is known as phase discrepancy protection. So this possibility is not there. This cause is not there in modern circuit breakers. So then the second fault in the stator winding of generator. If fault in the stator winding of generator or generator transformer occurs, then negative sequence current will flow. But then there are number of protections. You see, for generator, there is differential protection which operates in one cycle. For generator and generator transformer, there is overall differential, another one more differential. You see, right? Then generator has overheating protection provided by using RTDs. So there are many protections which are taking care of fault in the stator winding, and all faults are class A protection, and all faults are roughly 1 to 2 cycle operation. And negative phase sequence protection is time delayed because of negative phase sequence, heat is produced. I2 square RT. And because it is function of time, we can wait for some time till the generator is damaged. I mean, just before the generator is damaged, we have to take action. If we take early action, then it is quite possible that this imbalance is temporary. This imbalance, this imbalance, this this imbalance what we are talking about may be temporary. So negative phase sequence protection is time delayed, and all other protections are a 1 or 2 cycle protection. So fault in stator winding is not a question. So now only one reason remains, that an unsymmetrical fault, that is double line to ground or line to ground fault anywhere in the power system, that is on the line emanating from generator. You see, you just think of, after generator there is generator transformer, then there is bus, and then the line is emanating. On that line, if the fault is there, any unsymmetrical fault is there, that is taken care of by overcurrent and earth fault protection. That is taken care of by distance protection. If it fails, then overcurrent and earth fault protection is there as the backup. If it fails, then in the transformer secondary there is backup overcurrent. If that fails, that means 3 lines of protection fail, then it comes to negative phase sequence protection. My dear friends, I was in engineering cell in GB. Then GB, now it is not GB, now it is GSCCL, Gujarat State Electricity Corporation Limited. But at that time, everything, the transmission, distribution and generation was under GB. At that time, all forced outages were reported to me. For 3 years I was there. For 3 years I have not seen a single outage due to NPS protection. But the protection engineer cannot take anything for granted, because as I was telling to you, the cost of 2 into 660 megawatt generator is of the order of 1800 crores of rupees. So such a big costly generator, you cannot take it for granted, and therefore you have to provide the negative phase sequence protection. So now, once having seen the causes and consequences, we will see how do we protect them. Protection is simple. Protection is, we are detecting, we are harnessing, we are extracting the negative phase sequence current out of the 3 line currents, IR, IY and IB. You can see that there are 3 CTs. You can see that there are 3 CTs, and they are connected to NPS relay, negative phase sequence relay. 1, 2, 3, 4, 5, 6 are internal connections. You have to give auxiliary DC supply. It will give alarm also, and it will give trip also. Alarm at certain level and trip at higher level, right? That means if the negative phase sequence is beyond certain value, then trip. But it is lower value, then first alarm will be given, so that you can, the in-charge engineer, if at all he can take actions, the alarm is also sounded. So now with the next slide, we'll see how do we extract negative phase sequence. So negative phase sequence, this is, my friends, English electrical layer. This is nothing mine. Knowledge is nobody's. Knowledge is coming from somewhere. Somebody is inventing. One person is inventing. Einstein has invented E is equal to mc square. And then many people are studying E is equal to mc square. So knowledge is coming only from one mad person. Because the person who invents has to be mad. If he is wise, then he cannot invent. Only mad persons, only half-mad persons can invent, because they think in a new way. Why the apple came down? Apple fell from the apple tree. Why did it come down? Why did it not go right side? Why did it not go left side? Why did it not go upwards? Nobody of us thinks. If you think, you will be considered mad. But Newton thought. Isaac Newton thought, and he found out the very important law out of that. the law of gravitation, and we are using it. So we cannot invent, I cannot invent. I am not of that capacity. I am only trying to discuss what is already there in the market, which is already there in the world, right? But unfortunately, people are not reading books, people are not, or people may not have time to look at these things. So I am helping you all to, to learn things. So this is English electric relay, early English electric. Then that English electric became Alstom. Then it became Delhi Alstom. Then it became Areva T&D Limited. And now it is Snyder. I mean, person is the same. Factory is at Pallavaram, Madras. But different persons have taken up. This, when I took up, it was known as English Electric Company. English Electric Company also in India had the collaboration of JC UK, right? So it is basically G, General Electric Company, UK. So from that relay comes 1, 2, 3, 4, 5, 6. You have seen in the earlier slide. Then we feed this to the internal transformer inbuilt in the relay T1, T2, and T3, and T4. 4 transformers are there. T1, T2, T3 are doing nothing. They are stepping down to milliamperes. That means because relay cannot take amperes, therefore 1 ampere or 5 ampere is stepped down to the tune of 25 milliamperes. So IR, IY and IB, the signal proportional to IR, IY and IB are available in secondary of T1, T2 and T3. You can see very easily IR, IY and IB. Now what we do? The secondary winding is connected in delta. So this is IBR, you can see IB minus IR. So this is IBR, right? This is IBY coming. IBY coming, you can see IB plus IY plus IBY is equal to IB. So this is IBY. If I write IB, then the direction will be reversed. IY minus IB. But this is IBY. I have written like this. Right. So IBR and IBI. This is IRY. That this is IR. IR is this, right? IR is coming here, and from there, this IY is going out. So this is IRY. So these 3 line currents are there now. Now what I do? IBR I am passing through transformer T4, which is differentially connected, cross differentially connected, so to say. You can see it is crossed. Dots are showing it's crossed. So IBR here, actually IBR should leave, but IBR is leaving here because dot is here. So IBR plus IBR. So here it becomes 2 IBR. And that 2 IBR, 1 IBR is going like this, 1 IBR is going like this. And IRY is passing through this. So now what happens? IBR is passing through RS and IRY is passing through series combination of RT and C. Now RT and RS are specially rather they are the values are specifically taken. They are taken in such a way that we'll see in the next slide. Take the next slide. The next slide, if you see, RT and RS. So RT and RS and C, the relations are very specific. Relations are very specific. Relations are they written here? RT and RS. The relations are not written, but RS is equal to RT is equal to RS by 2. RT is equal to RS by 2. And XC is root 3 by 2 RS. So, I mean, it is so connected that IBR is passing through RS. So, V1 is equal to IBR RS. V1 is equal to IBR RS. You can see V1. V1 is voltage across IBR RS. And RT is RS by 2. RT is RS by 2. So IRY RT is value. RT magnitude is RS by 2. But it is in phase with IRY. And IRY upon omega C. IRY, that is IRY XC minus JXC. It's minus JXC. You can see that it is XC, IRY, XC. So X is minus JXC because the capacitive voltage will lead the current by 90 degree. So it is leading IRY by 90 degree and its value is root 3 by 2. So this is root 3 by 2 and this is half. And if you make the total, that is 1/2 square plus root 3 by 2 raised to square, then you will get V2. And you will get V2, which is 3/4 root 3 by 2 square, that is 3/4 plus 1/2 square, that is 1/4. 3/4 plus 1/2 is 1. So V1 becomes equal to V2 and total voltage is 0. So if you pass pure positive currents, then there is no output, then there is no output V0. Then there is no output V0. Means relay will not operate. And we take the another condition. I mean, this is the worst condition. Complete negative phase sequence. That is, we are changing the phase sequence, RBY. I mean, that may not happen. It may be in between. But we are taking the worst case. So here if you take, then V0 is very high. V0 is very high. And that V0 will pass through. Then that V0 is proportional to negative phase sequence current. Because this is purely negative phase sequence current. And this negative phase sequence current has to operate the relay. So now what is the relay? What is the relay? So we have just extracted NPS. So this NPS filter, figure 5.20, the earlier figure we have seen, that extracted NPS we are passing through rectifier because we have to, because the digital, I mean static relays deal with DC currents, DC voltages, DC signals. Therefore, it is rectified, right? Once on one side it is rectified. Second side, that AC current is passing through timer starter. One timer is started. And to that timer, we are giving some reference voltage. We are giving some reference voltage. That reference voltage is for trip. That means if the second harmonic content exceeds certain value, then timer is started. And that definite time is low set because the generator is going to be damaged. Therefore, it has to be low set. Few seconds, 2 or 3 seconds or 4 seconds. Small time. On the other side, that rectifier, it has given a DC signal, is passed through squaring circuit because our heat produced is I2 square. We have received I2 and I2 we are squaring. And I2 square T. So we have to integrate with T. So main timer, it is integrated and it is compared with K. This K is a I2 square T equal to K. K is a constant. And that K constant is different for different generators. It varies very widely. It varies from 2 to around 80. So for steam turbo alternators, value of K is different. For hydro alternators, value of K is different. So you have to set that K. K is settable. You can see that on K resistor, the variable sign is there. So you can set. So if it exceeds I2 square T is equal to K, if that is exceeded, then only the output will come. And when output comes, it is compared with a reference voltage once again. That means yet the negative phase sequence current must be there. If by this time negative phase sequence current is gone, then there is no need of trip. So it is once again compared with reference voltage. And from here definite time, after certain time we are coming. So comparator should give output and time should have elapsed. Then only the AND gate will give a trip signal. And my dear friends, this NPS is class B protection. It is not class A because fault was not in the generator, fault was on transmission line. So you need not trip the generator breaker. We will trip boiler and turbine, and then through low forward power relay, once again, class B will return to class A, but we will use the I2 square T equal to K. Then when we are doing that, what we do, we use the possibility of generator to withstand the negative sequence current, right? So the end logic is for that. So we wait for some definite time, and from comparator and gate, trip signal comes, and that trip signal, and we use the, what I was saying, we use the kinetic energy of the generator. Therefore, this is class B protection. This is not class A. Same negative sequence current is going to allow starter also. That reference voltage is low and timer is high set. We may set up to 7 seconds, 8 seconds, 10 seconds. And then alarm is sounded. What does it mean? That if the negative sequence current crosses 5%, then trip will be generated. But if it crosses 90% of 5% or 70% of 5%, say 3.5 or 4% or 3%, then alarm is sounded. That means generator is not in danger, but negative sequence current is flowing. So why negative sequence current is flowing? That reason the engineer can find out and can probably stop tripping. Because if trip occurs, class B is also going to result in class A finally. Class B is only for using kinetic energy of the machine. So class B is also hazardous. If class B trips, then also whole generator, turbine, everything is going to trip. So this is the circuit for negative phase sequence. This is the circuit for unbalanced currents. How we treat the generator, I mean, how we protect the generator from negative phase sequence. It rarely occurs, as I told you, because it is in the fourth line of defense. First defense is distance protection of line. Second defense is overcurrent and earth fault protection of line. Third defense is transformer secondary overcurrent and earth fault. Fourth defense is this. So the you can see if the army is fighting, then also there are lines of defenses. So usually fourth line of defense has never to fight, because first is fighting. If first cannot control, then second will come. Second will also very rarely come. Third, just next to impossible. And fourth, if I say impossible, then I am not wrong. Right? So this is in the fourth line of defense. If you want to use the algorithm for numerical relay, then what will you do? So in numerical relays, for comprehensive generator protection, negative sequence current protection is one of the functions of the relay. Because you see, in numerical relay, there are no different relays. One relay is looking after all protections. The withstand capability of a rotor for negative sequence current is specified by manufacturer in terms of integration of I2 square T dt. So that the manufacturer will specify. This integration of square of rotor current I2 is obtained by implementing a thermal model. You have to implement a thermal model. That means thermal model is thermal analogous model of the rotor has to be generated in the relay itself, which can compute the rotor temperature rise. And if this temperature rise crosses certain limit, then the alarm and trip will be generated. I mean, this is how the numerical relay works, right? So numerically also, the negative phase sequence protection is possible. With all that, my friend, I end this one abnormality. I do not want to take many abnormalities at a time. We will take one by one. Right? We will talk one by one. So if you want to learn, you have to stay tuned with me. I am seeing on LinkedIn that many viewers from Pakistan are interested. Many viewers from Malaysia are interested. Many viewers from Middle East countries are interested. I'm very happy because my students will always be interested. They know me. They have learned under me. But these people who do not know me, they are sending me comments on YouTube. They are sending me comments on my personal WhatsApp also. And they feel that they have not learned these things in university when they were studying. And right now they are working in this power system protection field. So they want to know. So certain people from UK are also, I am seeing. Probably from USA, I have yet to see. So I want to see that the whole world sees adapt me a day. Lakhs of people see adapt me. And that people can see if my viewers will share. My viewers are my ambassadors. Because we are small people. We do not have big advertisement network. We do not have lots of money to spend for marketing. So my marketing people are my viewers, all of you, those who view. And I am seeing that they are certainly sharing because in LinkedIn, I am seeing very new faces which are not known to me and they like and they rather appreciate also. I thank them very much that they are appreciating a good work being done. This is free of cost and you are free to share to as many friends as you like. I mean, there is nothing like copyright because the true knowledge has no copyright. So please read this. If you view, then only my view hours will increase. The YouTube considers 4,000 view hours as a stop. I mean, as a point, as a target point. So our target is 4,000 and we have reached hardly 700. So we want to reach that 4,000. And that is not for money. That is not for anything. That is for sharing knowledge. That is for a good purpose. So please stay tuned with Adapt Me. Adapt Me will be giving lots of videos one after another on power system protection. So my friends, till then, thank you very much and good day.